Welcome back to Solve with Techsolvi. Today we are going to start with we are going to solve this fourth sum problem. This is also a very interesting problem among the families of two pointers problem groups. So let's see what the description says. Given an array of n integers, return an array of all the unique quadruplets such that uh, A, B, C, D indexes are within the ranges of the list. A, B, C and D are distinct, okay, and the sum of the values of the elements of the list is should be equals to a target. Okay, so let's look into the examples. The first example says that okay, this is a given list, target is 0 and there are three possible combinations. Okay, this is -2, -1, 1, 2 and all those. So sum of all these numbers will add up to 0 only. Okay, this -2 and 2 will cancel out, this -1 and 1 will also cancel out and it becomes 0. Similarly for the other two list also. So one thing to observe is that we have to send out a list of lists, that a list of all possible combinations that's giving me the target value. Okay, second example is that it's a nums2 with a target 8. Now one thing to notice over here, there can be many combinations. At least I can see 3 combinations possible for this particular list of elements, but still the output has only one list inside. Okay, that means they are looking for unique combinations of values that's reaching the target. So we have to make sure we have to maintain the uniqueness in the response also. So this we have to also note. Second and the last thing is that the constraints. So you can see one thing, that the nums dot length is less than equals to 200. Okay, so this upper limit is quite small compared to the normal upper limit that you see in other problems, and the reason for this is the complexity. So complexity of solving this problem is not linear, okay, and definitely not constant time, and it will go to quadratic level, means something like O of n square n cube, like that. So we'll exactly see what will be the complexity of this. So that being said, let's dive into the problem solving. So okay, let's list down the requirements or the provided elements. So one is a list, that is nums. Okay, and here in this list you can see the elements are not in any kind of arrangement. Okay, that is elements are not arranged in neither ascending or descending, rather it's the elements are quite randomly placed. Okay, so one thing we should always remember that in two pointers problem or in a kind of pointer approach, normally the elements should be arranged within the list. Okay, otherwise we can't decide the, or we can set the logic for each of the pointers to how they will move. Okay, based on what condition, what relation they will move. To set those condition, to set those relation, we first need to have an arranged list. Okay, that's why this in this kind of problems you will observe the expectation will never be related to the original index positions of the elements. Okay, they will never ask. Even they ask, then it will increase the complexity of the problem, but ideally people won't ask you to give the index values of the positions of the values of the list. Okay, so they will always ask you the values but not the index. Okay, because anyways we have to do some kind of arrangement, some kind of sorting on the list. Okay, and then apart from that, also mentioned here we are dealing with 4 pointers, I, J, K and L. Okay, now when we are dealing with such more than 2 or 3 or 4 pointers, the first thing that should come in your mind is how many pointers should we fix and how many pointers should we keep as variable and we should play with. So in this kind of typical problems, ideally we should fix ideally we should play with at max 2 pointers. Okay, if we increase the pointers from 2 to 3, the complexity of managing those pointers increases quite a bit, and it's not that I'm not saying that we can't approach a solution, but point is that even if we do, it will be of higher complexity, and the code will become very heavy unnecessarily. And also within the stipulated time during any kind of interviews, obviously you won't be able to figure out the exact approach having multiple pointers, that is beyond 2s. Okay, yes, there are scenarios where you can uh, choose to work with 3 pointers, but those are very specific scenarios. In other problems we will look into it where to use 3 pointers, but here we will work with only 2 pointers. That means by default we have to fix the other 2 pointers. Okay, and then we have to proceed. So I think we have enough background as of now, so let's proceed with the coding. So nums dot sort is the first thing, then fixing first pointer to 0, and then setting the while loop for I will be less than len nums. Okay, and what will be the upper value of I, that is the maximum index value up to which I can go, is less than length of the array minus 3, because we are dealing with total 4 pointers. I, if we consider, since I'm considering I the first pointer, I have to also make space for, or keep the space for, other 3 pointers. So that's why the maximum position up to which I can go is length minus 3, less than length minus 3. Okay, so now when I is set, obviously I have to initialize j corresponding to I, and that will be I plus 1. So basically the relationship between these pointers are like this. Okay, so pointers, so I is the least position pointer and L is the highest position pointer. Okay, and j and k will be next to each other, where j being smaller than k. So we have to maintain this relationship. Okay, in that way we can avoid any kind of duplication in the sense that we will avoid reconsidering one element again and again. Okay, because we are constantly moving from lower values to upper value, from low to high we are moving, from 0 to towards length of num. Okay, and when we move, we'll move together. So if I goes up, obviously j and k and l will definitely will naturally will go up. Okay, the range of those pointers. So anyways, j being set, now let put the loop for j less than length of nums, and here it will become minus 2 with same logic as before for 1. Here for since I and j are set, I have to keep space for k and l. Okay, now with j being set, I have to initialize k is j plus 1, l will be starting at from the end position. Okay, that is length of nums minus 1. Okay, and the final loop for managing k and l. So I told you relation k should always be less than l. If anywhere it's breaking, this relation is getting broken, then that should be the condition to get out of the loop. Okay, so fine. Now what we have to do, we have to set the target by now is target minus nums I and nums j, right? So this is the target for based on which we will be working with k and l. Okay, so let's place it over here. So we have the target set. Now we have to check if t2 equals to nums I plus nums j. Okay, if it's equals to this, sorry about that, yes, that means we are reaching the, we have made this condition that the sum of all the numbers should be equal to target, right? So so we have to take this solution into consideration, right? So what I will do, let's consider set. So here I'm taking the intermediary result to be set. Okay, the reason being set because we have to avoid duplication. The set data structure by default will take care of it. Okay, and then here what we'll do, we create a tuple. Okay, tuple is a keyword, so let's be t. Tuple will be nums I comma nums j nums k nums l. Okay, so tuple is set. Here I made a mistake, it will become k and l. So you got the tuple, and in the set we have to add tuple. Okay, I've added the tuple. Now what we have to do, we have to place the condition for the pointer movements. So if t2 is greater than this, t2 is greater than the sum, that's in k and l. Okay, that means what, we have to increase this value. To increase this value, if we increase the kth index, that will lead me closer to t2 value. Okay, if t2 is less than this value, that means we have to reduce the sum, right? To reduce the sum, we will reduce the upper limit, which L minus equals to 1. Okay, otherwise if none of the condition is set, means it's like t2 is equals to, suppose if the condition is like this over here, then what we can do, we have to do k plus equals to 1 and L minus equals to 1. So we are bringing both the pointers closer to each other. Okay, so if we do k plus equals to 1, that means I am increasing the sum, but since I am doing L minus equals to 1, that means reducing the index of on the upper level. Obviously it will balance that, it will balance the increase, so it will, so basically it will kind of check balance. Okay, and from there we can start our search again. Okay, like that. So I think that being said, our k and l are getting incremented, that's fine. So now we have to get out of the last loop, and here we have to increment j, and similarly for I also have to write the incrementation logic plus equals to 1. Okay, I think that being done, now we have result is set, so we have to convert it to list. The answer equals to list of map of list of result. So this will convert the set of tuples to a list of list. Okay, now return answer. Let's check. Okay, so both the test cases got passed and it's giving me the expected response. Let's submit. And it got accepted. So that's all for today. Hope you liked the session. Don't forget to like and subscribe and stay tuned for more upcoming sessions.